Hey, welcome back. This is Mr. Kelly. We're doing lesson two. Lesson two is about trigonometric equations. That's hard to say. Trigonometric. Trigonometric. We also have to say words today like periodicity. That's a new word. And inverse sine, inverse cosine, inverse tangent. What? We're going to learn all that on page 835? No, not. It's not all on that one page. But we're going to start on page 835. Here's a worked example, and we've seen this before. Sully taught us a little bit about this. If we have to solve the equation sine of x equals a half, right? How did we do that in the past? Some of us would look at that and say, sine of x is opposite over hypotenuse. And this looks like one of those special right triangles. So if you get the special right triangle going, even if it's tilted back a little, we'll put a 1, 2, a radical 3 on it. We need the opposite to be 1 and the hypotenuse to be 2. That would be 1, 2. That'd be 30 degrees. Okay, so 30 degrees. But I have to change that 30 degrees into radians, right? Because we're dealing 0 to 2 pi. So 30 degrees into radians. This is a little review. That's all we're doing. How do you change into radians? You multiply by pi over 180, and then you simplify that fraction. It gives you pi over 6. But then you got to tell yourself, where is the sign positive? And sine is the y value. So the y value is positive in the first and in the second quadrant. So with a unit circle, that gives us this angle right here, which is pi over 6. It also gives us this angle. We need to subtract 30 degrees from 180, which will give us 150. And 150 will give us 5 pi over 6. Okay, you trust me on that. Or this is like 1 pi minus a sixth of pi will give us 5 pi over 6. And that's basically how we've done these in the past. That is a review, right? Well, here's a new way we can solve these trigonometric equations. Let's consider the equation x equals 1 half. Actually, I don't want to use red for this. I want to use blue. And this is why. Because my graph over here is in blue. Cosine of x is the blue graph. And this line is y equals 1 half. So that is the right-hand side of the equation. Someone might ask, why wouldn't you use red? It's a good question. So we have the equation cosine of x, which is in blue, is equal to 1 half, which is in red. So how can we solve this? Well, we know how to do this. It's where, we have two different sides of the equation. We can graph it and we can look for their intersection. That's a different way to do this. Now, the only tricky part about this is figuring out what these values are down here, because it's all fractions and all in radians, and that's pretty ugly. Well, let's answer some questions first. Identify the domain. Remember, the domain are the x values. So the x values start here at negative pi over 2 and go to 3 pi over 2. So I'm going to write it the way I always do in my inequality. It starts at negative pi over 2 and it ends at 3 pi over 2. And we're talking about x values, and we always put it like this. That is an inequality to describe the domain. X has to be greater than negative pi over 2, but less than or equal to 3 pi over 2. We've answered 1a. Now B, write the solutions to the equations given the domain restrictions, which means only on this graph. Then plot and label the solutions in the coordinate plane. Easy enough. We just need to figure out like what that x value is. Here's how I would do it. Like pi's right here, right? So then we got 1, 2, 3, 4, 5, 6. So the scale on here is pi over 6. That's what one line is. So this is 2 pi over 6. So x would equal 2 pi over 6. But we know that as pi over 3, right? That reduces to pi over 3. That's this value right here, pi over 3. And then x equals, that's the same distance on the left. So x can equal negative pi over 3 on the left over there. And they want us to write it as a solution here. All right, we can do that. It's just xy coordinates, right? So negative pi over 3 comma 1 half, and then pi over 3 comma 1 half. And that's how we do number 1. We got some more values here we can do. Well, let's look at it. Where does the cosine of x equals 1? All right, well, 1 would be right up here at the top. What's the x value for that? Well, that happens when x equals 0, right? So when we're at 0, the cosine is going to equal 1. Where does the cosine equal 0? Well, here's 0. Y equals 0 would be this line right here, right? So it equals here at negative pi over 2, at pi over 2, and at 3 pi over 2. Those are all the values where the y is equal to 0. That's easy enough. We could write those out. Part C, cosine of x equals negative 1 half. I drew the line there to help us. But what do we have here? We have this value and this value. These two values. So remember, these are sixths. So this is 1, 2, 3, 4, 6. So x would equal 4 pi over 6. That would be one answer, but that can reduce, right? 2 pi over 3. And what's the other value? 1, 2, 3, 4, 5, 6, 7, 8. So x would equal 8 pi over 6. But again, we can reduce that as well. What is that? 4 pi over 3. Fancy. All right, and where's the cosine equal to -1? Here's cosine. -1 is right here. That's where x equals pi. So that's how we can use a graph to help us solve for the x values, unknown x values here. 3, use the graph of y equals tangent x. Now, here's the thing to notice about tangent of x. As a review, this is a review, right? It starts at 0, 0, and it goes up. And at pi over 2, there's an asymptote, which means it gets closer and closer and closer, but it never passes it, right? And then it starts down here, negative wise, and then keeps going up. And you notice it repeats itself. That's going to be important a little bit later. It repeats itself. By the time you get to pi, you start again. You're in the same place. You're at the 0 again. You're going to go up, and then another pi later, and then another pi later, and it repeats every pi. It's a little bit different than our cosine curve, which repeats every 2 pi. You remember back on those earlier quizzes where if it asks you to find the period, which is how long it takes until it repeats, that for cosine it would be 2 pi over b, but for tangent it's pi over b. It's different for tangent. It repeats more quickly. But we'll get to that here in a second. 3a, find out where the tangent of x equals 0. Well, we've kind of already put the dots down for most of it. But we want to work between negative pi over 2, which is over here. Okay, so we start here. Where does tangent equal 0? So it's 0 at pi and at 2 pi. So x equals 0. X is going to equal pi. X equals 2 pi. Hold that thought. I'm going to come back to that. And where is the tangent of x undefined? Well, those will be at our asymptotes. So pi over 2. X equals pi over 2. There's no tangent there. And that was an ugly x. All right, so pi over 2 and 3 pi over 2, that is where tangent is undefined. But I said I was going to circle back, and I'm going to circle back right now. This is, what do we got? X equals 0, x equals pi, x equals 2 pi. What would the next value be if the domain was extended? The next value would be x equals 3 pi. And then x equals 4 pi. And then x equals 5 pi. And then, doesn't take a rocket surgeon to figure this out. You're going to keep going, right? Every pi. So I could just say, if you start at 0, you just go every pi. So x would equal 0 plus, just add pi to it. How many times? N times, where n is an integer. N is an integer. Integer. Hey, I got it. Well, that's where we're going. That is called, this happens, what, this repetition of tangent. Look, it's the same, it's the same, it's the same. It has a periodicity. Periodicity, that's how you say that word. We have periodicity identities, which I think this is a little bit it's not too complicated, but when it's written, it looks complicated because now you have an x and an n, and so students get confused about that. But essentially what it says is the sine of x is the same as whatever it was, or will be the same if you just add 2 pi to it. If you go down the road 2 pi units, you're going to get the same value. And then go down the road 2 pi units again, you'll get the same value. Remember that sine and cosine repeat every 2 pi. Tangent repeats every pi. So you could just add a pi to your answers for tangent, and it's going to be another answer. It's going to be another solution, as long as you're still within the domain of all the real numbers. So let's figure out these. Use the periodicity identity to list 4 solutions to each equation. So let's do the cosine of x here equals radical 2 over 2. Hopefully you recognize that this is rewritten form of 1 over radical 2. And this comes from our 45 degree right triangle, right? So 1, 1, radical 2. This is 45 degrees. And the cosine is the adjacent over the hypotenuse. So that would be this angle, right? Adjacent over hypotenuse. This is 1 over radical 2. That's what radical 2 over 2 is. So we're going to get an x value here that's equivalent to 45 degrees, and that's pi over 4. Okay, we should know, remember how to change it back. We already know how to do that. Now, according to our identity, if I want the next solution, okay, I can just add 2 pi n to this. So I'm going to write plus 2 pi n, where n is an integer, which means it just can't be a decimal there, right? So you just add 2 pi to it, 2 pi, 2 pi. Now, the other part we have to consider, where's the cosine positive? We have two quadrants we need to worry about. We just did the first quadrant right there, pi over 4, that's 45 degrees, right? But we also, cosine is positive down here in the fourth quadrant. That would be 360 minus 45, or we get 315 degrees. Or another way to think about it is 2 pi minus pi over 4. That is 7 pi over 4, right? I think that's probably a better way to start thinking about it. If you go all the way around, it's 360 degrees. That's 2 pi, or you have 2 whole pi, and we need to go back pi over 4. So you take a fourth away and you're left with 7 pi over 4, because this would be 8 pi over 4, right? I'm just reviewing some fractions here, so you don't have to do the whole formula every single time. But we're going to write this as well, plus 2 pi n. So basically what we have to wrap our head around the idea that we have this cosine function, and apparently we have a number line that curves. But this repeats itself, and we want to know where the cosine is equal to radical 2 over 2, which is about, what, 0.7? Okay, so it repeats the periodicity of it. Periodically it repeats. So you have one value, you have another value. This is in the first quadrant, this is in the fourth. Guess what? We're back in the first quadrant again. And then this will be in the fourth quadrant, and then the first and the fourth, and it just goes forever, right? So we take that first value, which was the pi over 4, and we add 2 pi to it, and it'll give us this value right here. And then we add 2 pi to that, and it gives us this value right here. But we can't forget about the value that's in the fourth quadrant. So we take this value and we add 2 pi to it, and it gives us this value. And then you keep repeating. So our two values here, x equals pi over 4, x equals 7 pi over 4. We're going to add 2 pi n to it, where n is an integer. All right? How about that? Ta-da! Let's try b over here. The tangent of x equals radical 3. So I'm going to write my special right triangle so we know where that is. So what do we got? This is 30. All right, 1, 2, and radical 3. So we want to know the tangent, which is opposite over adjacent, right? So the opposite has to be a radical 3 over a 1. So that would be this angle right here, which is 60 degrees. Then I have to think about the quadrants. So where is tangent positive? It's positive in the first quadrant and the third quadrant. So 60 degrees, which I know 60 degrees is going to equal pi over 3. We're going to run with that. Hopefully you know where that comes from. If not, ask your teacher. So it's 60 degrees here, but then it's also 60 degrees down here in the third quadrant. So it's 180 plus 60, or pi plus pi over 3. So for part B, we're going to get our first value here, which is 60 degrees, which is pi over 3. And remember, it repeats. So plus, now here's the thing with tangent, it repeats every pi units, not 2 pi. So it repeats every pi n. So it's pi over 3 plus pi n, where n is an integer. N is an integer. Forgot my n. Integer. Now my G looks, it's falling apart here. Where n is an integer, that'll give it to me. Now, what's the other angle? This is pi, right? So I add a third to pi, and I get 4 pi over 3. So that's pi over 3 plus pi. But here's the deal. Look, check this out. What's 1 pi over 3 plus pi? If n equals 1 pi over 3 plus pi. I get 4 pi over 3. I get the same one again. I don't have to worry about that one. That's the good part about tangent. We're all done. We only have to do it one time. Whereas with cosine and sine, you have to do it twice. You got to find both angles and do it twice. But with tangent, when you repeat the first angle, you're going to land on the second one. That is super cool. So now we're on page 837, and they have a worked example here where they have solved the square root of 3 times the tangent of x plus 5 equals 4. And the way I solve these, I like to put parentheses around whatever the trig function is, and then you just pretend that's a big ol' x, and you solve this equation. So you subtract 5, divide by radical 3, divide by radical 3, and you're left with the tangent of x equals -1 over radical 3. Okay, so doing the same type of things that we did before, they get x equals 5 pi over 6. So let's go from there and believe him here. 5 pi over 6. How would we write that for tangent if we wanted to show the solution set, all of the answers, on all of the real numbers? This is the same type of question that we just did. If we get an answer of 5 pi over 6, then we just need to add pi n to it, where n is an integer. Is an integer. Integer. Sound it out if you need to. And there you go. That's it. It says show your work. Well, look at the table from before. I don't know how they want me to show my work. There you go. That is the work. So now let's move down to number 3 here. Solve the equation 2 times the sine of x plus radical 3 equals 0. Now here's the tricky part about this equation. The domain here, negative 90 to positive 90. So it needs to be real close to the x-axis. All right, let's see if we can solve this. The way I like to solve these, we're going to get in equation solving mode here. We're going to put sine of x. I like to put it in parentheses. So I'm going to subtract radical 3 from each side, just like a regular old equation. I like to visualize this as a huge x. Oh, that sounds frightening. This is a huge x. We need to subtract radical 3 from each side. They will cancel. We're left with 2 times the sine of x is going to equal negative radical 3. And then when I divide by 2 on each side, I'm going to get the sine of x equals negative radical 3 over 2. Now I need to figure that out. We got to use our special right triangles. And we also have to remember that we're looking only within the domain of negative pi over 2, which is negative 90, to positive 90. So we know that the sine is the opposite over the hypotenuse. We have a negative radical 3 over 2. So we should say, oh, special right triangle, 30, 60, 90. This angle up here, which is the 60 degrees, will give me an opposite side of this radical 3 over 2. Okay, opposite side is radical 3, but it's negative. So where is sine negative? Remember, sine is the y value. Normally it's positive in 1 and 2, right? So 3 and 4, that's where sine is negative. But I got to work from negative 90 to positive 90. Well, negative 90 is right here. Positive 90 is up at the top. So it has to be within there. We're looking for our fourth quadrant angle here. But it's got to be a 60-degree reference angle. So when I draw a 60-degree reference angle right here, okay, what do I get? 60. Oh, that's 300. So we need an angle that is 300. But that 300 degrees, that is not within negative 90 to 90. How about if I just do negative 60? So negative 60-degree angle, that's what we need. That goes the other direction down here. So x is going to equal negative 60 degrees, but we need this in radians. I know that 60 degrees is pi over 3, so x here is going to equal negative pi over 3. Let me just review that again real quick. We solve it, we get x, we get the sine of x equals negative radical 3 over 2. We go to our special right triangle. I know that's 60 degrees. To be negative, I got to be in quadrant 3 or quadrant 4, so it's got to be quadrant 4 because I need my answer to be between negative pi over 2 and pi over 2. And negative 60 is between negative 90 and 90. Negative 60 equals negative pi over 3. Easy enough. Now we're going to learn about the inverse sine, the inverse cosine, and the inverse tangent. On our calculators, the calculator will work backwards and tell you what the angle is if you know what the sine is. Remember, we already figured out the sine of pi over 6 is a half. That was an earlier example. And it says Sophia and Tahir each use a graphic calculator to solve the equation, explain the differences in their answers. So let's check it out here. If you notice on your calculator, you have above the sine, the cosine, and the tangent. You have in blue, now mine is sine with a little negative 1 there. Now, if you call it sine and the negative 1, I'm going to shame you with my shame app on my phone. I'm going to yell shame at you. This is the inverse sine. That's how we say it. Inverse sine. It means work backwards, right? We know about inverses. They take you back. So if you want to know the angle, normally we know the angle, right? And then we figure out the sine. But if we know the sine and we want to work backwards and find the angle, then we use the inverse sine button. So inverse sine of, let's throw a half in there and see what it gives us in our calculator. Oh, it gives us, we got Sophia's answer down here. Great job, Sophia. We are the same. But Tahir got 30 degrees. And we know that the sine of 1/2 is 30 degrees. So what's this number that Sophia got? Well, that number is, well, quite simply, what angle? Well, it's pi divided by 6. We know that, right? Pi over 6, hey, it's the same answer. So What does that mean? Sophia's working in radians, and Tahir is working in degrees. So let's change the mode of our calculator. Radians, what is this? Radians over to degrees. If we change it to degrees, and I'm going to just scroll up and grab that inverse sign again, then we get 30 degrees like Tahir got. So they're just working in radians and degrees. But we're going to use that to solve equations. Page 838. Here's the deal. If we get a value we recognize, we're going to give exact answers. Otherwise, we will give approximations using the calculator. That's the rule we get. So let's check out A here. The cosine of x is like right here. All right, so let's solve for the cosine of x. We got to get that all by itself. The first thing we can do is get rid of that -5. If we add 5 to each side, check this out. All right, they cancel. So I get 2 radical 3. And something tells me that radical 3, right, that comes from our special right triangle. I bet something's up to do with that. So when we divide each side, we're going to divide by 2 radical 3 here. We'll divide this side by 2 radical 3. Notice we get the cosine of x is going to equal -3 over 2 radical 3. Well, that doesn't look familiar. So what I'm going to do is I'm going to rationalize this. Remember, we can't have radicals on the bottom. So it wouldn't look familiar because we would never use that. So I multiply by whatever the radical is, radical 3, top and bottom. This is going to give me -3 radical 3 over 2 times radical 9. And radical 9 is just 3. Well, look, this is all going to equal -3 radical 3 over 6. And that becomes -3 radical 3 over 2. So the cosine of x is going to equal -radical 3 over 2. Well, we already know the answer to that, right? So, I mean, I could draw my triangle over here, but that does look familiar. Here's 30 degrees. Here's 1, 2, and radical 3. And we want the cosine, which is adjacent over hypotenuse, to be radical 3 over 2. That's 30 degrees, or pi over 6. But we have to keep in mind cosine is negative, and that happens in the second and third quadrants. So I need pi, my reference angle is pi over 6, 30 degrees. So what is that, 150? I'm going to work in degrees here a little bit for us because I know some of us love those degrees. So I need to go 30 up and 30 down. That'll be 210. So I need the radian equivalent of those. 150 degrees into radians is 5 pi over 6. Remember, that's where cosine is negative, quadrant 2. And quadrant 3, so this is 210, so this is 7 pi over 6. So our two solution will be 5 pi over 6 and 7 pi over 6. But how do I write that? So x will equal 5 pi over 6. But remember, there's periodicity of this. It just repeats over and over and over and over every 2 pi. So I'm going to write plus 2 pi n. And I'm going to write x equals my other solution here, 7 pi over 6 plus 2 pi n, because it repeats over and over and over again. And then technically we should write for integer values of n. Integer values of n. Boom, dot di. We're done with part A. So essentially we go like this. We solve it for cosine, and then if it looks familiar, which this one does because there's a radical 3, so we should have a little alarm in our head going off. Then we solve it, we get their two values, and we put plus 2 pi n. It's not any much different than what we've done before. All right, let's look at letter B here. Letter B is a little different than what we've done before. To solve this, I like to put this in parentheses. All right, so we got to subtract 9 from each side. That gives us a -6 on the right. These cancel. We get 5 times the sine of x. Now we can divide by 5. And we get this number here of -6 over 5. So the sine of x is going to equal -6 over 5. Well, a lot of us will run to the calculator. Oh, that's not a common 6 and 5. That's not a common right triangle that we know. It's not a special right triangle. So we'll plug this in, -6 over 5. And I want to find, oops, I forgot to put the, we want to find what angle will give us a sine of that. So we want to do, let me start again. We're going to do inverse sine. Ooh, that's regular sine. Inverse sine of negative. I'm having a rough time with the calculator, I'll tell you what. It is not doing what I want it to do. It says error domain. Wait a second. Check this out. 6/5 That's 1.2. So this is equal to negative 1.2. Do you remember our sine curve kind of starts like this, is 0, and then it goes up, down, and up? What's the maximum value of our sine curve? It's a 1. Well, what's the minimum value? A negative 1. So the sine is negative 1.2. That doesn't happen. That's a no solution. So if you're solving these and you get a sine that's greater than 1 or less than negative 1, there's no solution to that. But remember, tangent can be greater than 1 or less than 1. All right, I'm going to do one more, and then you're going to do one. Pick one. All right, I pick C. So here's the equal sign. I like this to put these parentheses around it. Like I said, kind of helps me visualize it. I'm going to add 4 to each side. This is like a two-step equation. So I add 4, they cancel. So I get 6 times the tangent of x is going to equal, this gives us negative 15. Now I divide by 6. This is where a calculator is going to come in handy because 15 over 6, I can kind of reduce that a little bit. I can take a 3 out of both. So I get what? Negative 5 over 2, but that doesn't really help me out too much. So I'm going to go to the calculator. Hey, calculator. I want to solve for x. I want to know the angle, right? I already know the tangent. So let's quit this one. We're going to do second tangent. Okay, that's inverse tangent. And we're going to shame you if you call it tangent negative 1. I will shame you. And we plug it in there, and we get negative 1.1903. All right, so I'm going to write that number down, and it's kind of ugly. X equals negative 1.1903. All right. And then I remember about the periodicity of this. Tangent's a little different, remember. It repeats every pi. So I'm going to write plus pi n for integer values of n. And we write that out. And remember that with tangent, it repeats every pi. So I don't need to worry about 2 different quadrants. It's not like cosine and sine. It's your turn now, though. You do D. Oh, said it again. You do D right now all by yourself. Do D. Dude, I can't. I just can't. Okay, I did half of doing D here. I figured this is probably where we might get a little confused. So the cosine of x, hopefully you got down to 1/4. Negative 2 divided by negative 8. Let's throw this in the calculator. All right, so we're in radians, remember. So it's not degrees. What am I doing here? So the inverse cosine of negative 2 over negative 8. I could have used 1/4 too. That's okay. Either one. Your calculator doesn't mind. And I get 1.31. Okay, so that's how many radians, right? So cosine is, what do we get? Positive. Cosine is positive here in the first quadrant. It's also positive in the fourth quadrant. This is hard to think about because in radians, our brains just generally go to degrees, right? This is 180 degrees, but this is pi. So this is 3.14 radians. So if I go 3.14 radians, it's right here. So 1.3 is a little bit less than half of that. So it's in quadrant 1. But I also need to figure out what the value is down here. So let's write down the first one. That's the quadrant 1 angle. And we need to find the quadrant 4 angle. So this is 2 pi, remember? Or it's 0. Oh, we could do that. Let's just call this 0. This will be 0 degrees. And if I go this way, I just subtract this. Easy peasy. I can just subtract 0 minus 1.3181. So x is going to equal 1.3181. And then x is going to equal negative 1.3181. And then for each of them, don't forget to add the 2 pi n. And that means it'll go another 2 pi for each one of those and repeat itself. 4 integer values of n. So we're going to include those. Now, some of you might say, well, that's cheating because I did 1.3 on this side, and I need to go in this quadrant, so I'll just call it x equals negative 1.3181. Well, I mean, it's not really cheating because we want the values, we want all the values, right? So what if I wanted that positive value? How would I figure that out? Because that's something I know some students will ask. Well, it would be 2 pi minus this number. So we can do that in the calculator. All right, just type in 2 pi minus 1.31811, and I get 4.965. So I could have used that answer as well, because that's part of this solution. When I have x equals negative 1.31 and I add 2 pi to it, this is the number I get. And then I get another number, and I get another value, and I get another value as it continues forever, because this thing goes forever, right? So cosine goes forever down the number line. That's it. This video is way too long. I'm going to have to edit it out, but hey, good luck to you. What are we doing? This is lesson 2. This is Mr. Kelly in K-Town. Remember, it's nice to be important. It's more important to be nice. See you.